Hey Suril,
What's up?
you know what the new console's released? I thought you wanted to upgrade.
Yeah, bro, I seriously need to upgrade, man. This console has given me a lot of trouble these days.
But what are you gonna do with this?
I'm probably gonna try to sell it on eBay, and if that doesn't work, maybe I'll throw it.
Let's see some facts about e-waste and recycling. Most consumer electronics are decommissioned before they need to be, and certain gadgets such as phones and consoles cannot be thrown away because they are toxic and contain harmful materials. They must be sent to a specialized facility for recycling. The problem is, recycling isn't a public service, it is more of a business. And all that rich countries want to do is just get rid of them. And also, recycling e-waste can have adverse health effects on the population of a country because it involves burning, crushing, or acid bath. So, all that we can say is recycling is nothing but sending our trash to somewhere else. E-waste is now the world's rapidly growing waste source. It's a growing concern, and if you don't believe us, then take a look. So what is our solution to this grave problem? Our proposal is to repurpose old game consoles as servers for general computing tasks. So how do we do it? Step 1. Form a team with the smartest people on earth.
Hi, my name is Christopher Cha, and I'm a third-year CS student.
Hello, my name is Eric, and I'm a fourth-year CS student.
Hi everyone, my name is Dingye Chen. I'm a third-year C student.
Hi, I'm Colin, and I'm a graduating senior this year.
Hello, everyone. My name is Suril Shah, and I'm a first-year MS student in the ECE department.
Hi, my name is Nihal, and I'm a first year CSE master student. And now let's get this started.
Step 2. Design. So first, we get various gaming consoles such as Nintendo Switch and PS3. Then we install a custom firmware to it. Now once the firmware has been installed, we then run the operating system and test its functionalities. Now when the operating system is up and running, we then run a custom workload on it. When the custom workload has been running successfully, we then create various benchmarks for it. Then finally we quantify the CPU and the GPU performance. Step 3. The build phase.
So, we're going to demo the Linux and the PS3 through SSH. So we're going to show you the version of Python here, 3.10.4, latest stable version, GCC, also version is 12.1.0. And so now quickly we're going to show you a matrix multiplication benchmark. And so we're going to run 100 by 100 matrices multiplied together 10 times, and let's see how long it takes. And here you go. You can see Python code running. And here I will even show you the code for this. And here you go. You can see this is Python code. So yeah, there's not much more to show because the PS3 Linux doesn't have a graphical interface. But yeah, that's the state of our project. I would say we definitely achieved a lot this quarter, and I'm proud of what we accomplished.
Now, in order to run a custom Linux build on the Switch, we first need a modified bootloader. And this is something that will enable us to run a custom firmware from the SD card. So the bootloader that we decided to work with here is called Hecate, and is extremely stable and can run the Ubuntu build that we were targeting. Now we will show you a short demo of how the Switch is booted into Ubuntu.
The RCM loader is an external device with the Hecate bootloader built in. So for the first step, we'll insert it into the USB port of the Switch. Next, we'll remove one of the controllers and install an external jig instead. In order to boot into Hecate, we'll press the volume up key and the power button simultaneously, and this will enable the Switch to boot into Hecate. Next, we'll go into more configs, and then we'll boot into L4T Ubuntu.
So we ran multiple benchmarks such as the matrix multiplication, image resize, KNN, Fibonacci, and PyBench on PS3, Switch, and i5, and these were the results of each of the consoles.